my screen now.
Doreen, please share your screen.
Please, I can't share. It's telling host disabled me from sharing. So can permission be granted, please? Good afternoon.
Yeah, I think I was asking for those who are supposed to present, and I don't think this fellow showed up.
Sorry, sir.
Yeah, I said when I was asking for those who were going to present, you didn't raise up your hand.
Oh, I'm sorry. It was a network glitch. I didn't hear, sir. I'm very sorry.
Yeah, you can decide to. Yeah, you can continue presenting. Yeah, if you are speaking, like we can. Yeah, it appears you are muted. The person who is supposed to present, you can unmute yourself and present. Or can anybody hear the fellow presenting?
No, we can't hear.
So no, sir, I think she's having network issues. Sir.
Okay, probably we'll just wait a bit for her.
Okay, sorry, sir. She just sent me a message that a laptop went off. She's about to put on again. I want to start when I'm done, she will pick it up from there.
Yeah, are you able to share your screen?
I'm about to put up. Can everyone see this?
Yeah, we can see your screen.
All right. Actually, she ought to start from the mean value theorem for differentiation, but I'm going for the integration aspect and also the Taylor's theorem. So mean value theorem for integral, just like we know about. Sorry, good afternoon, everyone. My name is Roland Sainde, presenting for Group 6. So I'll be talking in the aspect of the theorem for mean value theorem for integration and also Taylor's theorem. So because of time, I'll very fast as possible. So just as we are familiar with mean, finding an average of the data be given to us, just an ordinary data, so we can sum up those values and divide by the total number of the data. So by that, we can get the mean of that data set. So, but in this case, we are talking about a graph for an integral. So this one is a continuous function. So it's almost still the same thing. We're looking for the average, or let me say the mean value of the continuous data set in a graph. Take for instance, just like the graph we have here, the one on this particular one. We can see a graph. Maybe let's assume here is 1, 2, 3 in that manner. So the continue to get the average of this continuous function, we that is what we are talking about here. So that is the meaning of the mean value theorem in short. So the mean value theorem for integral states that a continuous function on a closed interval takes on its average value at the same point in that interval. So what this place is trying to say is that assuming you have this graph, oh sorry, okay, you have a graph from point A to B, having C at the center. So the mean value rectangle here, that is the area of this rectangle. The area of the rectangle here is f of C into B minus A. F of C into B minus A, that is the area of, that is the average. Then we have the area of the curve as integral, this curve here as function of x dx. So that is why we came about this formula. So the mean value theorem for integrals, you can use either of this formula or this. We'll still arrive at the same, but I'll be using both formulas while doing some of the examples. So if f of x is continuous over an interval AB, then there is at least one point C as element of A, B, such that f of C, such that f of C is equal to 1 over that interval AB, B minus A of the curve f of x dx. This formula can also be stated as the curve f of x dx is equal to the area of the rectangle and the first interval is B minus A. So we are going to look at some examples. Sorry, I have to write this out and snap it. So I'm sure you can all see the screen. So before we go into the examples, our basic knowledge of integration is very important because we can't just start this if we don't have the basic knowledge of integration. So we can all remember that this is the formula here. Remember we have integral x raised to power n dx. So and the function we have this, let's assume any value raised to the power of that x, we are summing it up, we are adding one. Unlike differentiation, whereby when we are differentiating, we subtract one from the value. So we are going to have x raised to power n plus 1 over n plus.
Excuse me, Mr. Presenter. Now, the integral sign, is that S or somebody with a big head? That's not the sign of integral. It should be just slightly curved, not writing S. So probably when you are doing the correction on your slide, this should be corrected and effected too.
Thanks. Okay, so thank you for that, sir. So we have x raised to power n plus 1 over n plus 1. So for example, we have integral x raised to power 2 dx. So the 2 is going to, the 2 stand for n here. So 2 plus 1 over n, which is the number that is raised to the power, which is 2 plus 1 also. So we are going to have x raised to power 3 over 3 plus the constant c. So from here we have integral x squared as 1 over 3 s raised to power 3 plus c. Now let's quickly go through the examples that we have here. We want to find the average mean value for this function. So it's a continuous function from a point, from one interval to another. Let's check the first one. F of x is equal to 3x raised to power 2 minus 2 from point 1 to 4 at this point. So we can remember that the formula states that A stands for 1 here, then B for 4. Let's look at this. So from the formula, I'm going to use the first formula here, which says that f of x is equal to 1 over b minus a. So we are going to use that first formula, and also in other subsequent example, I will also use the second formula to solve those exercises that we have. Now, f of x is equal to 1 over b minus a. So a is equal to 1 and b equal to 4. So 1 over 4 minus 1 here, you have 1 over 3. So the integral here, we are starting from a point from point 1 to 4. Now we have f of x. F of x here is 3x raised to power 2 minus 2x. So f of x is 3x raised to power 2 minus 2x. So when we integrate this value here, we are going to have 3x raised to power 2 plus 1, just for as the example that we did earlier. 3x raised to power 2 plus 1 over 2 plus 1 minus 2 raised to power, minus 2x raised to power 1 plus 1 over 1 plus 1. So when we sum it up, we have 3x raised to power 3 over 3 minus 2x raised to power 2 over 2. So when 3 cancel out 3, we'll be left with 3 here. And 2 takes out 2, will be left with x raised to power 2. So we still have our 1 over 3 and sorry. So we have 1 over 3 as x raised to power 3. We bring in 4. So you are going to have, I'm sorry about this. So we are going to have x raised to power 3. And here we are representing with the first interval, which is 4. So 4 raised to power 3, we have 64, into 4 raised to power 2, we have 16, minus x raised to power 1, we have 1, minus x raised to power 2, we have 1. So 64 minus 16, we have 48 here. 1 minus 1, we have 0. So 64 minus 0 is 60. 48 minus 0 is 48. So we have 1 over 3 into 48. So that gives us 16. So the mean value or the interval that is C of this function 3x raised to power 2 minus 2x is 16. Now let's check out the other example. So we have f of x is equal to x raised to power 2. Now, here we can also integrate that value, and we are going to have, so when we integrate the value there, so from a point 0 to 4 also, I think from point 0 to 4, so the integral for x raised to power 2 is going to give us x raised to power 2 plus 1 over 2 plus 1. So we are going to have x raised to power 3 over 3. That is the integral for x raised to power 2. So using the second formula now, that is integral the first point to the second, that is b a, f of x dx is equal to f of c into b minus a. So we are going to have x raised to power 2 from the point 4 to 0 ab. sorry, A is 0 and B is 4. So f of C
Yeah,
is
please, can
20.
you show the example you are solving? Because I think the last example used 0 and 4 and 1. Have you changed the wording of the example?
Yeah, this is another example. The second example, I'm using 0 and 1.
But let's see the, okay, where is the equation you are using? Okay, this is 3x squared. Where
This
I
one.
can't see it
This is
clearly.
the,
Okay,
this is the first equation, 3x squared minus 2x.
okay. So where is the second one you are explaining now?
I'm explaining x raised to power 2. Just f of x is equal to x raised to
Oh,
power 2.
okay, okay. I think I understand. And the intervals are 0 to 4.
Exactly, sir.
You can
So
continue.
I'm using the other formula. So the first one, I use the first formula for the first one. So the second one, the second formula, this is what we have here. This is the formula here. So from point A, which is 0 to point 4, that is B. So when we integrate x raised to power 2, we are going to have x raised to power 3 over 3. Sorry, I wrote x. I'm sorry about that. I'm going to correct that. From an interval of 0 to 4. So when we take a 4 minus 0 is 4 multiplied by c raised to power 2. That is 4c squared. Now, this is from point 4. Now we are going to have 4 raised to power 3 over 3 minus 0.0 raised to power 3 over 3 is equal to 4 c raised to power 2. So we are going to have 64 over 3. That is 4 raised to power 3 will give us 64 over 3. Then this is 0. Then 4c squared. So we multiply both sides by 1 over 4. We are going to have 16 over 3 here. Then this 4 will cancel this 4. We'll be left with c squared. So we square the square root of both sides. We are going to have c is equal to plus or minus 4 over, that is the square root of 16 will give us 4, and the square root of 3. So in decimal, we're going to have it as 2.309. So the mean value for c in this function x squared. Sorry.
Yeah, I think somebody is requesting that you show the formula so that you can write it down on the
Okay,
chat box. So you should be checking the chat box as you also present.
Okay, this is the formula. We have the two formulas there. Can you see that?
Yeah, I think the person
go
has
ahead?
responded by saying yes.
Can I go ahead?
Yes, please.
Okay. So we are going to have so dividing this, we are going to have it in a decimal as 2.309. So I have one more, okay, two more examples. Let me just be very fast. So we have f of x equal to 2x plus 3 from point 2 to 10. So when we look at the integration for this, we are going to have, it's important that we do the integration for somewhere you can just, because that is the what you have to have known before, now just the basic understanding about that. I said that earlier. So we are going to have 2x raised to power 1 plus 1 over 1 plus 1, that is 2, plus 3x. So using, I'm still going to use the second formula again for this. and I'll use the first formula again for the last one. So I just shared it to 2. So from point 2 to 10, so A is 2 and B is 10. So 2x plus 3. C also is 2c plus 3. So we just change the x that's there and replace with c. So we are going to have b minus 2 is going to be 10. Sorry, 10 minus 2 rather is going to be 8. So we also have the integration of this. The integral for this is going to be 2x squared over 2, like I said earlier, plus 3x from point 10 to 2. So looking at both points, we are going to have 2x, that is x into 10. That is 10 raised to power 2. 2 into 10 raised to power 2 over 10 plus 3 into 10 minus 2 into 2 raised to, 2 into 2 raised to power 2 plus 3 into 2. So we are going to have these two, remove this, we are left with 10 squared, that is 100, then 3 into 10, we have 30, minus 2 raised to power 2, we have 4, 3 into 2, we have 6. So this thing remains here because we are looking for C, which is the mean value. So we have 130, that's 100 plus 30 minus 4 plus 6, that is 10. So we are going to have 120 into 2c plus 3 into 8. So divide both sides by 8. We are going to have 120 over 8 into 2c plus 3 over 8. So we are left with 8 into 20, we have 15. Then we are left with 2c plus 3. We are actually making c the surface of the formula so as to get the mean value. So we are going to have, when you subtract 3 from both sides, we are left with 12 equal to 2c. Divide both sides by 2, so c is equal to 6. So the mean value for that continuous interval for the point 2 to 10 is going to give us 6. So the last example, I'll be using the first formula also. So we have y is equal to 1 plus x raised to power 2. So
who is that one disturbing? Can you mute yourself?
So from point -1 to 2, I'm sorry about that, I didn't say that. We are using point -1 to 2. So it means that A is -1 and B is 2. So we are going to have 1 over 2 minus 1. That is going to give us 3. So we are going to have 1 over 3 from points -1 to 2. So f of x here is 1 plus x raised to power 2. So when we integrate this, we are going to have x here, 1 return to x, then here will be x raised to power 2 plus 1 over 2 plus 1. So we are going to have 1 over 3 into x plus x raised to power 3 over 3 from point -1 to 2. So 1 over 3 into 2 from point 2 plus 2 raised to power 3, 8 over 3 minus, so we input -1 in the other part also. So we are going to have minus x plus -1 over 3. So doing the mathematics, we are going to have 2 as our final answer here. So 1 is going to be 18 over 9, and that is going to give us 2. So the mean value for this is 2. So in summary, the mean value is actually looking for the average of a continuous function in a graph. So that is all about the mean value theorem for integral. My other colleague will talk about the differentiation. So I want to really go straight to Taylor's theorem. So I'm going to use a Word document because of the formula I have here. So Taylor's series is a polynomial or function of an infinite sum. So it's like, for instance, now with differentiation, when we are differentiating a number, we can keep on differentiating that number until we get probably to its minimum. Now, this is the formula for that. Sorry. So Taylor series is the polynomial or a function of an infinite sum of terms. So each successive term will have a larger exponent or higher degree than the preceding term. So the first one, which is f of a plus f power a, sorry. So f of a plus f into a factorial 1 x minus a plus. So as it is increasing, the next function is also increasing. As it's going, it's increasing by the power. The function, the factorial, everything are increasing as it keep on moving. So I will quickly go through the examples because of time. So my other colleague will have time. So I will use the formula to solve the examples that we have there. Just using the formula also. I still have the formula down. So we want to determine the Taylor series at x equal to 0 for f of x, x. So for here, when we differentiate the given equation, f of x is still the same. Differentiate further, we still have the same thing. If we differentiate further, we still have the same thing. So at point 0, so we get, if we put 0 at x, so it's going to be 1, 1, 1. So using the formula up there, when Taylor series at x is equal to 0, then so sorry, I didn't say this. Maclaurin series is also almost the same thing with the Taylor's series. So we are going to have this. The first, look at this is the formula. So f of x here is 1. We can see it here. Into x raised to power 2 over 2 factorial into 1. So x is 1. For every value we have here, x is 1. So this is 1, x here is still 1, and x here is 1. So therefore, e raised to power 2, e raised to power x is equal to 1 plus x raised to power 2 over 2 factorial plus x raised to power 3 over 3 factorial. So let's look at the other example using the same formula. So we are going to differentiate cos x. So if we differentiate cos x, we are going to have minus sine x. We differentiate further, we still have minus cos x. If we differentiate further, we have sine x. Differentiation of minus cos x is sine x. We differentiate further again, we are still going to have this. So we still keep on having the same. So until we get to this place, so we have this at the least value. So according to Taylor series expansion, so we want to impute each of these values, the value we have for f of x, and the first differentiation, the second, the third, fourth, or to the fourth. So here, f of 0 here is 1. That's at point 0. Point 0 here also. So x is 1. 1 times 0 will give us 0. Here is 0. minus 1 over 2 factorial plus, we are adding each of these values. So F3, we have it as 1 also. So we put 1 in this place. So we arrive at this. So cos x is 1, this 1, 0 minus x. You have minus this. This 0 plus this still give us this. 0 minus 6, we have this until you continue in that form. So if you keep on differentiating, so it is a continuous process. Now the last example, so when we differentiate this at x is equal to 3, this is going to be x. If you differentiate this first one, you're going to have 3 x raised to power 2. That is 3 minus 1. This 3 comes here. So you have 3 minus 1, you have it as 2, 3x. Then this one multiplied by this, you have 20. X minus 1, you have x. Then this becomes 0. So at point 3, if we put 3 in this point, so you're going to have 3 raised to power x minus 10 into 3 raised to power 2. And you are going to have minus 57. The same thing here, you differentiate this further, you're going to have 2 multiplied by 3, you have 6. 2 minus 1, you have 6x. 1 multiplied by 20, you have 20. So this becomes 0, x becomes 0. Sorry, 1 rather. It will be 1 minus 1, you have x raised to power 0, which is 1. That is 20 minus 1 becomes 20. So at point 3 for this differentiation, you are going to have 3. For the next one, the same thing, you have 1 multiplied by 6. You have 1, then x becomes raised to power 0, then you have it as 1, and this is 0. So 6 minus 0 gives you 0. So this is the function. So if we differentiate this further again, 6 becomes 0. So therefore, the required series equation for this. So for at point 3, the first factorial you're going to have is at 3, you have it as 57. That is this first differentiation, you have it as minus 57 rather. Then the second function, the second differentiation, you have it as 33. So you're going to have 33 minus. That is into x minus 3 minus x into minus 3 raised to power 2 plus this. So this will be the formula for the series, for the Taylor series. Thank you very much. I'm also going to put the questions as my colleague will proceed from there.
All right, thank you for your presentation. Well, before, lest I forget at the end of the presentation, now, most of the documents that you guys have presented, that's presenter 1 and presenter 2. Now, the idea is that you should come up with just one document that can be shared on the WhatsApp group for your colleagues to also look at, so that they will be able to learn from it. Aside from looking at the audio or the video presentation, they should also have the document that you have used. So in these slides, all of you will bring your documents together on a PowerPoint presentation and also submit a binded copy of your notes, of the general note that you use in formulating this class notes. Now, I also observed that most of your writings, like the ones you did on paper, they were a bit dark. So probably you look for a white sheet of paper, then maybe a well-illuminated phone, so that we'll be able to get the details of your presentation clearly, like those ones you wrote on paper and you snapped. Then I found out that when you were presenting, I had to shift my screen down. Some of those things were too high up, so you could almost see some of them escaping your screen, and you feel that you have lost something. Maybe you have lost track of what is being presented. So make it brighter, so that at least will be, or maybe you use black pen on very clear white paper. Then instead of snapping them, you could scan them, then upload them to your PowerPoint. So I think that would be better.
All right, sir.
Yeah, so the same thing for the first presenter. Of course, maybe your writing should be bigger. That's what my comments are. So where is the last presenter? You should raise up your, or how many of you are in group one?
Sir, sorry for the disruption earlier on.
How
laptop
many
got
people
stopped.
are in group one?
4, sir, but one person is unavailable.
Why? He has withdrawn from the program.
She hasn't given us a definitive answer yet. Then she will get back to us before next class if she's withdrawing or she's staying.
And maybe she should withdraw because she has lost the mark awarded to presentation. What was I saying? So you should raise up your hand so that I can make you a course that you'll be able to share your screen.
Okay, sir.
Yeah, I can't see the, okay. Yeah, you have dropped your hand again. I can't see. I didn't say you should raise up your hand on the chat group on your, just by your name. Okay, just put on your mic. I will see you and make you a call.
Okay, sir. Sorry, sir.
Yeah, so you can share your screen now.
Okay, good afternoon.
Yeah, there appears to be a lot of clicking sound where you are. Are you at a site or somewhere?
Something like that, sir. And I'm actually charging my laptop because it's very, very low, so I can't leave here. So very sorry for that, sir. Okay, so the topic is mean value theorem for differentiation. The definition of mean value theorem states that for any function f of x whose graph passes through two given points, a, f of a, b, f of b, there is at least one point c, f of c on the curve where the tangent is parallel to the secant passing through the following.
Yeah, we're just seeing your front page. We're not seeing anything you're displaying. We're just seeing the first mean value theorem and your name. That's all we see.
Oh,
you should go to the next slide.
I'm at the next slide, sir. Oh, you're not
your
seeing.
Next slide is not showing. We're just seeing your name.
Okay. What of now, sir?
Yeah, it has moved out, so you can continue.
Okay. So like I said initially, the mean value theorem states that for any function whose graph passes through two given points, a, f of a, b, f of b, there's at least one point c, f of c on the curve where the tangent is parallel to the secant passing through the two given points. So one of the best ways to explain this is that we know basically when we are talking about mean, we are talking about the average. And when you are talking about differentiation, you just want to know a change with respect to x. So mean value theorem for differentiation basically will be running through this, we'll see a graph that has each of these, the average with respect to x. So there are several conditions that have to be met for mean value theorem for this differentiation to be done. One of them is that the closed value interval, if you notice right here, for the closed value interval, we have square brackets, right? And for open value, we have curved brackets that are parenthesis. So for the closed value interval, it has to be continuous. That is, there must be no break jumps or verticals. The first presenter showed a graph that had a circle that was showing a break. So in your case of graphs, there are times you see that when you draw a graph, after you insert your values, you have a line that is above. Sometimes there's a line going straight, then there's a break, meaning there's a space in between, then the line continues. So for mean value theorem to be done, there should be no break at all in the line. In the case of the open interval, it has to be differentiable, meaning if we cannot differentiate our values, our functions, then we cannot look for the mean value. Then the C value should be the same as the average rate of change that should be in between A and B. In our mean value, there's something we call a secant, and another line we call a tangent line. The secant line is the line that touches 2 points of a curve. If you look at this graph here, there's a line A and B. Now, this third line, C, that's where this third point comes in. The C value should be the same as the average rate of change and should be in between A and B. So in the case where you have your solution, let's say A is equals to 1 and B is equals to 3. C cannot be 5 and C cannot be -1, because now it's no more in between these two numbers, 1 and 3. So for every time you are going to solve for C, always ensure that your C value is in between A and B. If not, your answers are actually wrong. The last point is that the second line have to be parallel to the tangent line. So from our graph here, we see the top part, we wrote one as M-tan and the other as second. So like I said earlier, the second line is the line that touches 2 points of the curve. Why the tangent line is that line at that point that touches one part of the curve that indicates our point C. So for our mean value theorem for differentiation, there's a very clear formula. It states f of C equals to f of B minus.
Excuse me, please. Now, I think you have just mentioned two important concepts. One is the second line and also the line C, where the line touches the middle. And I think you should create a section where you explain that, because most people here do not have the background in mathematics, right? So I think you should explain into details so that they will be able to understand what you're explaining, as it were, right? So that they don't get lost. Of course, a mathematician may not need that explanation. And that's the reason why I'm asking some of you to come present, most of you to come present, so that it will be from your colleague, not me just pushing things down your throat. And probably you are not even able to ask questions and all that. So the essence is not for you to just pass a course, it's for all of you to be carried along, right? So please, anything you make mention of, it should be well explained and defined before, at least in your slides, so that at least everybody will be able to make use of it.
Okay, so what would happen is that for the final slide I'll be submitting, I'll put a detailed information on the second line and the tangent line, but for now I'll just explain it with my mouth. So
that's what I said, that it should be put there.
Yes, sir.
And
so
it ought to have been here.
Sorry, sir. That was a mistake on my end. I'll make sure it's there for the final work that will be submitted. Very sorry, sir. Okay, so I'll do a quick recap on the second line. At our point A and B in our graph, in the curve, right? That line that goes through.
Are you using your system? Could you use your cursor to point out where the point A and B? Of course, okay, I can see your cursor now.
Okay, so at point A and B, this line that goes through this from A to B is the second line. Then the tangent line is that line that touches just 1 point of the curve. That's this point here. When it goes through, it touches 1 point of the curve. And there's one thing we need to note, that at every point, your second line needs to be, your second line has to be parallel to the tangent line. Meaning you cannot have a line going straight like this as your second line. Then you have a line that is moving to the left or moving to the right as your tangent line. It needs to be coordinated at every point. So there's another graphical representation of our second line, right? So it doesn't matter the way the curve goes. What is most important to us is that at any given point where the second line touches two parts of our graph, our tangent line have to be also parallel. So what the mean value theorem basically does is help us find the value of C between this point A and point B. That's what our mean value theorem will do for us, where the value of the tangent line is equal to that of the second line. So we'll run through examples real quick. So the first example is if we have f of x equals to x squared minus 4x plus 1, and we have in our bracket here the closed interval, we have it as 1 and 5, x in between 1 and 5. When we want to solve, we can remember our formula from the very beginning. I wrote that f of c equals to f of b minus f of a over b minus a. And from our conditions over here that I said that one thing we need to realize that there must be no break in our graph. So let's imagine we were to draw a graph. What I'm trying to say at this very point is that if you go through our graph, when we look at the value from 1 to 5, if this were to be 1 and this should be 5, there should be no break. So it's a complete parallel line, or it's in a quadratic equation. It's a complete line that does not have any break at all. So when we input our formula, the first thing we are going to do, now this number 5 now, it's our B, and 1 is standing as A. Definitely when we are putting alphabetical orders, this would be A, this would be B. Now we solved for B first, where B equals to 5 squared. That's we put in 5 where x is, because we're trying to look for f of x. It becomes 5 squared minus 4. You open your bracket and you put in the value of 5 plus 1. So when you run that through with your calculator, the square of 5 is 25. And when you see a bracket, a number in a bracket, it means you have to multiply. 4 multiplied by 5 is 20. So it becomes 25 minus 20 plus this one that nothing was attached to it. 25 minus 20 is 5 plus 1 is 6. Now for the value of 1, f of 1, we fill in the same way we filled in the gap with our alphabet here, we fill it in with the numerics. So we do 1 square minus 4 into bracket 1 plus 1, 1 minus 4 plus 1. When you get your f of 1 would be, that's your A now, f of A equals to minus 2. Then now to our main calculation to get the mean value. Because at the end of the day, what we are trying to get is the value of C. So from our principle of differentiation, that's where
observation. Please, can you go to the this slide? Now, when you have example y for first equals to yes, this
sir.
place. You have f of where you have f of x.
Okay, yes, sir.
Yes, this example 1, that's where I'm going. So you have f of x to be equal to x squared minus 4x plus 1, given the condition is between the interval of 1, 5. Now to solve, you have f of c to be, now this is the formula, right? fb minus fa, like that. Now, by the time you are substituting for 5, now you say that, okay, f of x equals to 5 squared minus, okay, this. So where does the f of c equals bracket open f of b, where does it come in from?
Sir, so we come in here, I just so that the explanation in the other part examples that I would give, I just aligned everything, but to show where all this is coming from, that's why I gave it in, I separated each of the calculations. So if you look at
well, I feel that in that example, you should just, to solve, maybe just substitute x into the given equation.
Okay, sir.
For x equals to 5, that's b now. Then the next one, substitute this for x equals to 1. Then later you now bring in this f prime of c equals this to complete your solution. That's what I feel, so that it doesn't confuse people who are not used to mathematics.
Okay, sir. Okay, sir.
All right.
Well, sir. So we differentiated the other part, because we are not just talking about our mean value, but then there's a differentiation to be done. So from our regular formula for differentiation, where divide the x, we are saying we multiply our value of whatever is here, we bring it down to the front value. Let's imagine this wasn't just x squared but 2x squared. When 2 multiplied by this value up front, it becomes 4, right? But in this case, you know, when there's no value showing in the front, it means that it's automatically 1. So 2 multiplied by 1 will give us 2x. Now this value, this superset here, this number 2, right? You now minus 1 according to our formula from here. So you get 2x minus 4. Now, because 1 does not have any value for x, by the time you want to get the derivative of this, by the time you differentiate, it automatically becomes 0. Right? In this place, it was already 1 minus 1, 0, x raised to power 0 becomes 1. So 4 times 1 gives us 4. Now we put it to x minus 4. Then if we go to our previous slides, like we saw, we got the value of b and we got the value of a. Now we fix it in over here. So it becomes 6 minus, you open your bracket, minus 2, close your bracket, divided by 4, which is the value b minus a. That's 5 minus 1, which gives us 4, right? So 2x minus 4 becomes equals to 8 over 4. When you divide your 8 by 4, you get 2. Then we collect like terms to be able to solve it to the smallest form. When we collect our like terms, it means we're moving 4 across the equals to sign. So it converts from a minus sign to a plus sign. So it becomes 2x equals to 2 plus 4, which is 6. Then we divide both sides by 2 because we want to get indeed the value of x. Then x is equals to 3. And that's the same value of our function prime c. The example 2, we have f of x, x equals to...
Can you spare me a minute, please? Okay, now, sorry for badging. For those of you who are online, please, can you put in your name, your matric number on the chat? Then for those of you who have presented today, please put your group so that we'll be able to differentiate those who have presented and those who have not. So please, you could do. Thank you.
Yes, sir. So for our next question, we have f of x equals to x raised to power 2 over 3. Now, one of the reasons I placed our calculations with graph here is that when you put raised to power 2 over 3, then it becomes okay. Yes, are you sure we can differentiate and all? And can you remember we said there are conditions to solve our mean value? It has to be continuous, it has to be differentiable. So in this case now, if we go through sorry, I'm very, very sorry for that. I think there was a mistake. So, okay, sorry. If we go through our graph, right, with as simple as this is as 0 and 1, looking for the between with the value 0 and 1, it's easy to say that there's probably going to be little issues. Yes, in your open interval, actually, you can differentiate, but in your closed interval, you can't differentiate. Well, in your open interval, it just simply means that 0 is less than x, the value of x is greater than 0, but it's still less than 1. So yes, differentiation can still occur. So the same way we did for the first one, where we use the end value to multiply the first value in front of the x, that's the same thing we did there. So x becomes 2 over 3x raised to power minus 1 over 3, because when you minus 1 from 2 over 3, it becomes minus 1 over 3. Then we insert our values, the 1 and 0 for f of x. And so when we run that as our calculation, right? So we have in the function f of b minus f of a, it gives us 1 minus 0 and over 1 minus 0. So this is basically what we get. We get 2 over 3x raised to power minus 1 over 3 equals to 1 minus 0 over 1 minus 0. 1 minus 0 is 1 over 1, right? So we just cross multiply, because when we look at the function there with 2 over 3 raised to power x, right? The x raised to power 1 minus 3. We bring the, even though it's not showing here because of the way our crossover sign is, we brought the value of x down here, so it becomes 2 over 3 x raised to power 1 minus 1 over 3. Then if you notice this 1 over 1, yes, the answer is 1, but to make our solution or to make our calculations a little bit simpler, that's why we did not just insert the 1 immediately. We cross multiply so that we can have an easy way in calculating. So we have 2 equals to 3x raised to power minus 1 over 3. Like I said before, we want x to be standing on its own, not x raised to power 1, x raised to power 2, x raised to power minus 1 over 3 and all. So we divide both sides by 3. When we divide both sides by 3, we have to...
Sorry, I think what you have as the first line, 2 divided by 3x in bracket, is that minus 1 over 3 or raised power minus 1 over 3?
It's raised to power minus 1 over 3, sir.
That's not what it depicts. So you could just go to your Word document. There's where we have fonts. So superscript, you can get it up. You just highlight it and put superscript. So it goes up for all these ones you have written. Because all I'm saying is 2 divided by 3x in bracket minus 1 over 3.
Okay, so I'll work on that, sir. I'll work on that. So by the time we are done with our calculation, our final answer will be x equals to 8 over 27. For the example 3, now example 3 is very peculiar because we are going to be dealing with absolute values. Now in the case of absolute values, the first thing we have to do is to bring out the numbers from inside our lines there. So we try to solve that first thing first. 4x minus 5 equals to 0. Then we do our calculations. 4x equals to 5, x equals to 5 over 4x equals to 1.25. Now, remember we said there are conditions to be met, right? And one of them is that the lines must not break. But now, if you were to draw a graph with these values we have at x equals to 1.25, we actually realize that it doesn't meet the condition because there's going to be a break in the graph. And the moment there's a break in the graph, it means that the calculation cannot be done. So the mean value cannot be applied because even though the graph is continuous, it has a sharp turn inside interval. Now, if we go back to our conditions, right here, we say there should be no break, jump, vertical. Now, for any value to be differentiable, there must be no sharp break. Now, in this case, we have a sharp break right here. Sorry, I'm using my finger instead of my cursor. We have a sharp break right here, and because of that sharp break, this here won't be differentiable, and if it's not differentiable, we cannot actually work on it. So over to our fourth example, we have an example with our values being -1 and +1. And from our formula, like we said, we solve for this. So the first thing first, we differentiate. Now, one thing that is very clear is that in the case of polynomials are always differentiable. That's the good thing about polynomials. So this is a perfect example of a polynomial here. So we have x raised to power 3 plus 4x. So we differentiate. By the time you differentiate this, you automatically get 3x squared plus 4x when you differentiate this value. Then the next thing we fill in the f of b minus f of a over b minus a. Your a is -1, your b is +1. So when you fill in these values, you can remember here x is in a cube form. So 1 times 1 times 1 give us 1 plus 4 multiplied by 1, which is the same thing as 4. This for our f of b. We've solved for this one. The next one is for the f of a. So we have our a here as -1. So we put in the value of -1. Now, -1 times -1 will give us +1. But we are multiplying these things 3 times. So that +1 now multiplied by -1 again, it automatically makes it minus. So now instead of getting a positive at the end of the day,
can you start rounding up, please?
Yes, sir. This will give us a negative. So we fill in our figures, and at the end of the day, when you run through your calculation, this is what you would get. Then the final example. Now, instead of just numbers, we decide to take this as our case study. Now, in situations where we have square root, we know at that point we need to change the formulation to make it easy for us to work with. So when we change the square root, it became x minus 4 raised to power 1 over 2. So like I said initially, I'm going to try and change this to a superscript so it doesn't look like app. So the figure there is x minus 4 raised to power 1 over 2. We fill in our values where it's supposed to be filled in. So in the case of B, we put in 8 minus 4 minus the square root of 4, which is our value of x here, 4 minus 4 over 8 minus 4. So we feel when we feel this 8 minus 4 is 4, then we are looking for the square root of this becomes 2. 4 minus 4 is 0, the square root of 4 is 0. So when you do your 8 minus 4 here is 4. When you fill in this value now, 2 minus 0 is 2 over 4 over this. By the time you cross multiply, you divide where necessary. At the end of the day, x will be equals to 5. Thank you very much, sir.
All right. Thank you for your presentation, the group members. Now, of course, we have just 8 minutes. Do we have questions from the participants? Any questions from the participants? All right, so we assume that all of you understand. Now, I think I just have 15 names as against the 20 students present for the class. So I don't know why others have not put their name. So by the time I end the class and I copy the attendance, you should just understand that you're absent. It's that simple. So, okay, so my comment generally is that being the first set of people to present, they have done a very good job, especially the first and the last presenter. Now, the first presenter presented very eloquently. The second presenter appears to be a very cool person, just very slow presenting. And of course, his slides were giving him a lot of problems. And also, particularly to mention, you found out that the last presenter had to go to a welding shop, a welder shop, to go and plug a system to be able to present. Well, that shows the dogged nature of the Nigerian never give up spirit. Yeah, some people would have given up and they prefer to just throw in the towel. So we commend the last presenter for that ingenuity, for at least thinking out of the box to get somewhere to get self sorted out. Yeah, I want to also probably ask the class to grade the presenters from the scale of 1 to 20 based on their performance, use of multimedia, use of their presentation skills and everything. So it's going to be a group mark, whereas I'm going to give, no, I think it should be 10 marks, 1 over 10, 1 to 10. So I think I'll give the second mark, which will make it 20. So I'll award it. So for their presentation and every other thing, please, the class, you could grade them so that we can have the average of their scores. So you could start grading them now. You could send in what you have on the chat group, your grade, that's from 1 to 9. Yeah, we just have one person grading. We expect the others to. All right, so we have an average of, so I think the average grade should be about 9/10. So the first group will have a group average of 9 marks over 10. So for individual presentation, I'm going to award the other grades. So with this, we have come to the end of the first class. Now, for those who have presented, we expect that you do all the correction on your slide. And also the slide should be sent to the group chat where everybody will have access to the material. And for those of you who would want to check out their presentation, you could go to my YouTube channel and look at what they have done so far, right? So that's so I think I want to stop the recording also. But, yeah, so you could look up the and get the just for your own use, right? So those are the things just want to pass across. So we expect that your slide, those of you who have presented, your slide should come in to the group latest by Wednesday evening. So by 11:59 p.m. on Wednesday. Then for those who are going to do the next presentation, your slide should come in by Friday, 12 noon, so that others can look at what you have to present. So I wish you a pleasant weekend. We'll see you next week.